loaded some libraries into R, and we have also loaded data from an Excel file into R, and we can see the data here. So we have 19 variables here, and we want to explain the life expectancy LE with a few of these other variables: dev, HIV, ICR, AC, and PV. Okay, so we want to make a multiple linear regression model. How do we do that? We have a function called lm in R, and we want to regress LE, and then we use the tilde symbol. We want to regress LE on all these other variables, so dev and HIV and ICR and AC and PV. Okay, so we just use plus signs here to show that we want these explanatory variables in our linear model. And the data should be the data that we have loaded into R, this data that we have loaded already from our Excel file. Okay, so we write data equal to data. Now let's see what happens if we run this. Alright, so we get some output here. We get the coefficients for these variables. But in a regular output, we usually have more information. How do we get that? We can use another function called summary. And we want a summary of the above here. So let's call that MLR, multiple regression, multiple linear regression. And we do a summary for this. Okay, so we get a more comprehensive output. We have the coefficients, the standard errors, the t-values, and also the p-values. And note that these p-values are two-sided. And we also have the r squared and the adjusted r squared here. Okay, so what can we see? Well, some of the variables are significant and some of them are not. We have a really high p-value on this last one, which seems insignificant. So maybe that could be excluded. You have to, of course, analyze it and reason on it before you do. So let's take the model, the same model, and let's call it MLR2 in this case, and just exclude this PV variable and see what happens. Okay, we get a new model down here without the PV variable, and the p-values for the other coefficients, they change. And also the r squared and adjusted r squared are a little bit different, so you can compare those. Well, how about if we want to see if the variables, the explanatory variables, are correlated? Well, maybe we can do another model here, and let's now instead explain dev, this variable, with the remaining three variables. So we use these explanatory variables to explain the dev variable and also the summary here. Okay, let's see. Okay, so does there seem to be correlation between the explanatory variables? Well, here we have significant variables. So the ICR and the AC, they seem to be correlated with the dev variable. So you can also analyze that and reason on that. So those are a few things you can do, and then you write your reasoning and you choose the variables that are the best and that fit your theory